In this video, I will discuss some interesting facts about the Hebrew calendar, an elaborate timekeeping system that took its present form in the 10th century. I will compare it with the Christian lunisolar calendar, which originates in the ancient Hebrew observational calendar that existed at the time of Jesus Christ. Both calendars were developed together, and both aim for the 15th of Nisan to occur during the first full moon of spring. Today, both calendars are designed differently, but share many common elements. The Hebrew calendar is lunisolar and computational. It follows the apparent movements of the sun and the moon and is governed by mathematical rules rather than astronomical observation. The calendar follows the Meton cycle, discovered 2,500 years ago, according to which there are approximately 235 lunations, or lunar months, in 19 solar years. Lunar months are understood as those that begin with the new moon. Since 235 is not divisible by 19, there are two types of years. 12 are common, with 12 lunar months, and the remaining 7 are abundant, or embolismic years, and have 13 lunations. To apply Meton's cycle to a calendar, it is necessary to know the number of days in the cycle, which gives rise to various types of Meton cycles. The duration can be obtained by establishing the days of the cycle as a starting point, as Meton did, who assigned 6,940 days to his cycle. Another possibility is to set the average solar year length as the datum. This is what the Christian calendar does, based on an average solar year of 365.25 days, i.e. the year of the Julian calendar. A final possibility is the one adopted in the Hebrew calendar, which establishes as data the length of the mean lunation, or average time between two new moons. If we multiply the lunation by 235, we find the average length of the Hebrew Meton cycle. A distinction must be made between the true lunation, the time between two new moons, and the mean lunation, an average of the previous ones. Since the movement of the moon is strongly perturbed by the action of the sun, the true lunation is variable and can be more than 14 hours ahead of the mean lunation, either leading or lagging the mean lunation concerning the astronomical one. The mean lunation is always used in computational calendars, such as the Hebrew one. The mean lunation is easy to measure, and a precise value has been known since the time of Babylonian astronomers. Solar eclipses occur at the time of the new moon. If we know the dates of two solar eclipses at the same place, then the mean lunation will be the number of days between the two eclipses divided by the number of lunations, or lunar months. By this procedure, ancient astronomers could find the mean lunation to within 1 second. The mean lunation used in the Hebrew calendar has a value that is very close to that of the astronomical one. Therefore, this calendar follows the moon very exactly, in the sense that the astronomical new moons coincide, approximately, with the molad, or new moon deduced from the calendar. The Hebrew calendar assumes that the Meton cycle is exact, but this is not the case, because the solar year deduced from the cycle is 6 minutes and 13 seconds longer than the tropical, or seasonal year, a cumulative amount which, as we will see later, is a significant defect of the Hebrew calendar, which has no self-correcting system, as does the Christian calendar, which has periodic adjustments of both the lunation and the year, to prevent their durations from deviating excessively from astronomical values. Knowing the length of the mean lunation and the time of the first molad, that is, the molad of Tishri of year 1, which is also called the molad of Tohu or the molad of Beherad, we can determine the molad for any subsequent year, thereby finding Rosh Hashanah, or beginning of the year, and its other characteristics. It may seem that the events of the year of Tohu, in whose final day's creation took place, determine the calendar. But the opposite is true. The calendar determines the characteristics of the year of Tohu, particularly the date of the first molad, an indispensable element in preparing the calendar for any given year. The dates of the events that occurred in the year of Tohu will depend on the calendar we use. The Hebrew calendar has evolved from the primitive observational calendar to the current one, changing its rules and even having several calendars in use simultaneously. It is usual to read that creation began on Sunday, the 25th of Elul, since according to the Mishnah, man was created on Friday, Rosh Hashanah, in the year 1. We call this way of counting the years the Anno Mundi Old Style, or Wead style. But these dates are incompatible with the current calendar, where it is not permissible for the year to begin on a Friday, since if the molad of the year were Friday, Rosh Hashanah would be delayed one day. The old style was derived from a calendar in which the dehiyot, or postponements, were not yet defined, that is, when the year began with the day of the first molad. As we will see later, the so-called molad of Adam, or molad of Wead, or the first molad after creation, was Friday. This means that the next day, according to the current calendar, was Rosh Hashanah, which was Saturday. So the molad of Adam was Friday, the 29th of Elul, and the beginning of creation was 6 days earlier, that is, Sunday, the 24th of Elul of the year of Tohu. The counting of the years in this style, which we call modern or Beharad, is from the beginning of the year of Tohu, which is associated with year number 1. So, the year immediately after creation was year 2, which is year 1 in the old style. The molad of the year of Tohu, that is, the molad of Tishri of that year, which did not exist because it was before creation, is the reference for calculating the moladot of subsequent years. Another matter to consider is that according to tradition, in the year of the universal flood, the moon and the sun did not have their own movements, that is, movements relative to the stars. However, they moved relative to the earth because the days followed one another, that is, the earth continued to rotate around its axis. For calendar purposes, it is as if the year of the flood did not exist, therefore, we do not count it in our current calendar. However, there is the option of counting the year of the flood, which is supposed to have the same characteristics as the year of Tohu, a common year of 12 months, and an abundant year of 355 days. In this chronological option, we assume that the sun and the moon moved in the year of the flood and accept that the year of Tohu did not exist. This chronological style coincides with the current calendar only for dates after the flood. As we have said, it is necessary to know the date of the first molad, or molad of the year of Tohu, in order to find the molad, or new moon of the calendar, in any other year. This allows one to know the characteristics of the calendar for that year, that is, whether the year is common or abundant, the number of days in the year, and the day of the week of Rosh Hashanah. To determine the date of the first molad, we need the date of a new moon in any given year. Then, going back in time, we can find out the molad of Adam, and from that, the molad of Tohu. It is easy to determine the length of the mean lunation by the method of eclipses already discussed. With a small error, we can determine the date of any true new moon, but what we need as a reference is the date of the mean new moon, and this cannot be found out by observation, but by astronomical theory. The date of the molad of Tohu in the current calendar was determined using the tables of Ptolemy's mean conjunctions collected in the Almagest. In essence, it consisted of taking as a reference the date of the first mean conjunction of Ptolemy, which corresponds to March of the year 3014 of the creation of the world, and subtracting from it the time elapsed since the molad of Adam, or the first molad after creation, and we will have the date of the molad of Adam. Finally, if we subtract the 12 lunations that elapsed in the year of Tohu from the molad of Adam, we find the date of the molad of Tohu, which, as we have said, is the one we take as a reference. By making the previous calculation, we find that the molad of Adam was on Friday at 13 hours and 230 halakim. Those who devised these calculations thought that a molad as significant as Adam's should be a round number, so they added 850 halakim to it, making Adam's molad occur on a Friday at exactly 14 hours. From this, we deduce that Tohu's molad was 12 lunations earlier, or on a Monday, 5 hours and 204 halakim of Hebrew time. Since Adam's molad was on a Friday at 14 Hebrew hours, we can determine the events of the year of Tohu. Since the Molad was on a Friday, Rosh Hashanah was delayed one day and fell on a Saturday, the first day of Tishri of the year 2, after the completion of creation, which took place entirely in the year of Tohu. Since Adam's Molad was one day before Rosh Hashanah, it must have been the 29th of Elul, or the last day of the year 1. Adam sanctified the Molad when he was created, so the first man was created on the same Friday as the Molad, and the beginning of creation was 6 days earlier, that is, the 24th of Elul of the year 1. The current lunation used in the calendar lasted 29 days, 12 hours, 44 minutes, and 3.3 seconds, and was adopted in the 8th century. The previous lunation was 3.3 seconds shorter. The new lunation allowed the definition of the helek, a submultiple of the hour that is very useful for arithmetic calculations, and that some believe to be of Babylonian origin. The definition is 1 hour equal to 1080 halakim. A simple repetitive calculation shows us that the helek is the smallest submultiple of the hour, allowing the mean lunation of the calendar to be expressed as an integer. In fact, the lunation is 765,433 halakim. The helek has another property. When developing 1080 into prime numbers, we verify that it has remarkable divisibility properties because it is divisible by 2, 3, 4, 5, 6, 8, 9, 10, 12, 15, and many more divisors. In the Hebrew calendar, neither minutes nor seconds are used as time, but rather halakim. Furthermore, there is no need to use a submultiple of the helek, because all the quantities used in the calendar are whole numbers when expressed in halakim. As we have said before, the Meton cycle used in the calendar has 7 embolismic years, or 13 months, but which years of the cycle will be the embolismic ones? The 13-month years must be distributed regularly in the 19 years of the cycle. Since 19 is not divisible by 7, the regularity cannot be perfect. However, it is possible to distribute the 7 embolismic years almost regularly in 19 different ways. In reality, it is a unique way. The rest only differ in the year in which we begin counting the cycle years. The current calendar considers that the first cycle of Meton began in year 1 of creation, and that the remaining cycles follow from here on. Although several proposals for intercalation rules have been put forward, the one currently used is that embolismic years will be those in positions 3, 6, 8, 11, 14, 17, and 19 of each 19-year cycle. Distributing the embolismic years as evenly as possible is not the only criterion the intercalation rule must meet. It is also necessary that the 15th of Nisan, the festival of Pesach, occurs during the first full moon of spring. Before the calendar used the current intercalation rule, it followed the astronomical method to determine when to intercalate the embolisms. If the 15th of Nisan happened to be before spring, an intercalary month was necessary. The spring equinox date was determined by its position in the Julian year, in which the seasons occur on approximately the same dates. From the 4th century onwards, Christians placed the equinox on the 21st of March, and this convention lasted until the end of the 16th century. However, since the Julian year's length differs from the seasonal years, the equinox dates were increasingly earlier. Although the Christian calendar did not consider this seasonal shift, the Jews did and recalculated the equinox date to regulate the intercalation of the 13th month. They continued to fix the equinox date in the Julian solar calendar. With this astronomical method of regulating the embolisms, the calendar followed a fictitious 19-year cycle, just as the current Chinese calendar, which, despite being exclusively astronomical, follows the 19-year Meton cycle. It is possible that from the record of the embolismic years deduced by the astronomical method, the intercalation rule that we follow today was discovered. Although the inception of the computational calendar is supposed to have occurred under the Nasi of the Sanhedrin, Hillel II, in 358, it was not until the 10th century that the intercalation ceased to be astronomical and the calendar was established in its present form. This represented a major change in the calendar, because it meant that the length of the lunation regulated it and not by the motion of the sun, as it must be for the 15th of Nisan to fall on the first full moon of spring. In other words, the error was in considering the Meton cycle of 19 years and 235 lunations to be an exact period. The Christian calendar continued to be regulated by the astronomical method, requiring that Easter, which corresponds to the 15th of Christian Nisan, be celebrated immediately after spring. At first, it was believed that spring occurred on a fixed date in the solar calendar, but this error was finally corrected in the reform of 1582. When the Hebrew calendar became independent of spring, its regulation was done exclusively with mathematical rules, and this was the cause of its greatest defects. Since then, the spring equinox has shifted along the calendar dates, so spring and the other seasons occur at increasingly earlier dates, and consequently, Passover is celebrated closer to summer. Since the solar year derived from the Hebrew calendar is 6 minutes and 13 seconds longer than the seasonal year, then every 232 years, the seasons shift 1 day on the calendar, meaning they occur at earlier dates. This shift is permanent and will continue into the future. If it is not remedied, Passover will become a summer celebration rather than a spring one. As we have said, we established the intercalation of the 13-month years according to the year's position in the Meton cycle. But we must also require that the 15th of Nisan, the beginning of Passover, occur on the first full moon of spring. When we analyze the calendar at the beginning of the 10th century, we find that both of the above requirements were fulfilled. Specifically, the 15th of Nisan always occurred immediately after the first full moon after spring, which we assume was the 14th day of the lunar month, and it never occurred on the last full moon of winter. Thus, the calendar worked correctly. However, 1,100 years later, we find that in 4 years of each Meton cycle, the 15th of Nisan coincides with the second full moon of spring, meaning the calendar does not work well. Since the solar year of the Hebrew calendar is longer than the seasonal year, the date of the beginning of spring shifts in the sense that it arrives earlier and earlier. For example, in 2024, the first full moon after spring was on March 25th, and the second full moon was on April 23rd. This year, the 15th of Nisan was on April 23rd, therefore, during the second full moon of spring. This problem will occur in the following years: 2027, 2035, 2038, and 2043, and in general, in years 3, 8, 11, and 19 of the Meton cycle. As a final point, I would like to present some ideas on the reform of the Hebrew calendar, specifically, proposals to make the 15th of Nisan celebrated on the first full moon of spring, stabilizing the seasons in the calendar. This reform will require 2 operations, similar to those applied when Pope Gregory XIII reformed the Christian lunisolar calendar in the 16th century. The first thing to do is to restore the calendar, that is, to make the changes so that the 15th of Nisan once again coincides with the first full moon of spring. The second operation is to make the necessary changes to avoid the shifting of the seasons in the future. The second part of the reform is more straightforward to devise, although challenging to implement, because it would have to break with more than 1,000-year-old traditions. Some authors have proposed that the 19-year Meton cycle be changed and a longer cycle be applied, from which we can deduce a solar calendar year closer to the astronomical value and reduce the shifting of the seasons. Making a simple study of lunisolar cycles that are less than 1,000 years long, I find that the best cycle is 725 years long and has 267 embolisms. Its year differs only 3 seconds from the seasonal year. The 353 and 706-year cycles have solar years that differ less than 7 seconds from the Gregorian year. Naturally, when using a cycle other than Metons, we have to change the rule for intercalating the embolism years, although the criterion for their distribution is the same as that stated above, that is, distributing the embolisms as regularly as possible. Zeilberger proposes using a lunisolar cycle of 1,727 years, of which 636 are embolismic, so there will be 20,360 lunations in the cycle. If we continue to use the same lunation as in the current calendar, the solar year deduced from this cycle will differ by only 15 seconds from the Gregorian year, which is very close to the seasonal year. Feldman suggested another calendar reform that was less radical than Zeilberger's, because it maintains the 19-year cycle with a slight modification. The years are divided into blocks of 334, in which there are 17 cycles of 19 years with the same characteristics as the current cycle. However, the following cycle, corresponding to 18, is not completed but ends in year 11, although maintaining the usual distribution of the embolismic years. The new Feldman cycle has 4,131 lunations, from which we deduce a solar year that only deviates 0.69 seconds from the tropical or seasonal year and 29 seconds from the Gregorian calendar year, differences that guarantee a minimal displacement of the seasons. More problematic is the first part of the reform, which is to make the necessary changes so that the 15th of Nisan coincides with the first full moon of spring. We cannot make corrections of one or more days, because then there would be no coincidence between the molad and the astronomical new moon. Therefore, we can only make corrections of entire months, that is, removing embolismic months, which will not change the lunar character of the calendar. Nowadays, the calendar is moving forward in the sense that spring falls earlier, so it is necessary to remove days from it, which we achieve by removing at least one embolismic month. One option I propose is that in the 19-year cycle, when we make the reform, we count until the 17th year, and the following year, a new Meton cycle begins, with the same characteristics as the current one. With this correction, we remove 30 days from an embolism month. With this simple modification, the calendar is restored because, from this reform, the Passover is again celebrated at the beginning of the spring season. If we only made the above change, the calendar would function correctly for about 500 years, after which a new change would be required. A final option that I mention is to remake the calendar so that it is astronomical, like the current Chinese calendar, which is regulated by the winter solstice. That is, to return to the calendar that existed before the 10th century and in which the intercalation was based on the date of the spring equinox. Some people think Passover should be celebrated during the spring without having to be celebrated during the first full moon of that season. Then, the calendar would have worked correctly for thousands of years, and when a correction is necessary, it would be enough to eliminate an embolismic month. In short, experience has shown that making a calendar change is very difficult because of the need to break with well-established traditions. Furthermore, a calendar reform would require a detailed investigation into the various fields affected by the calendar. I hope that what I have explained in this video has interested you.